Look, up in the sky. Is it an avian critter? Is it aerodynamic hardware? Hang on while I put on these special glasses to take a look.
Now you can see the landscape visibly darkening. I'm looking toward the west to see if I see the shadow of the moon coming in our direction.
A total eclipse of the sun is a sight not to be missed, as I experienced in China during the 2009 total eclipse.
This is it. Yeah, hang on. This is going to be it. It's now dark enough that street lights have come on.
So you can bet your footwear I'll be in Oregon for this one, my 7th. The moon blocks the sun every 18 months or so somewhere in the world, but this year it's going to be visible from sea to shining sea here in the United States. Tens of millions will be able to experience this event, some driving for an hour or two to be in the moon's shadow. Excitement for the Great American Eclipse is heating up. We'll share why so many folks are going loony over this exceptional event. So grab a map, find the state of Oregon. That's where it all begins. I'm Seth Shostak.
It's very dark here. It's simply as if it were night, except for the very bizarre phenomenon that around the horizon it's fairly light.
I'm Molly Bentley. Welcome to Big Picture Science, produced at the SETI Institute, where researchers investigate the nature and origin of life. On Big Picture Science, we step back to get the wide-angle view on science and technology. This special episode prepares you for the solar eclipse of 2017. Where to watch, how to protect your eyes, why your pets might start behaving oddly, why the FAA is concerned about the behavior of pilots of private jets. Yes, it's eclipse mania, but it's not often you have a chance to see 70 billion tons of moon rock block the sun.
Seeing an eclipse is something that everybody should experience. It's just the most wonderful experience that anybody can have, and this is for the general public, not just for scientists.
You see the shadow of the moon racing across the landscape, the last little bit of the sun being covered. Then there's a flash like a diamond ring where the moon's last valley hides the light of the sun, and suddenly the sun is completely covered by the dark face of the moon.
Today, we know that the roiling inferno of hot gas in the sky is a lot of hot gas. At its center, where temperatures reach tens of millions of degrees, is a nonstop fusion reactor turning hydrogen into helium.
Prior to the 20th century, however, we didn't know what made the sun shine. Our star was an enigma, and solar eclipses offered an opportunity to unravel some of its secrets. But Europe was the epicenter of eclipse research, much to the chagrin of the U.S. So when a solar eclipse that would traverse America rolled around in 1878, American scientists seized their chance to outshine Europeans' dominance. A research race was ignited, and that feverish competition is the subject of a book by writer and former NPR reporter David Barron.
But before we join the eclipse-obsessed folk of the Gilded Age, let's find out what produces eclipse fever. After all, it was a serious contagion way before Oregon hotels were booked up for August 2017.
Astronomers are not the only ones infected with eclipse fever, although you can easily catch it from them.
David Barron remembers how he caught the bug in 1994 when he was on assignment and an astronomer told him, "Before you die, you owe it to yourself to experience a total solar eclipse."
Well, that astronomer was Jay Pasachoff, and Jay emphasized that even a very deep partial eclipse is absolutely nothing compared to the glory of totality.
I'm Jay Pasachoff. I'm a professor of astronomy at Williams College. I do tell that to a lot of people. Seeing an eclipse is just the most wonderful experience. I tell everybody I know.
Jay's enthusiasm was so infectious, it prompted Mr. Barron to travel to Aruba for the 1998 solar eclipse.
And he was absolutely right. A total eclipse is like nothing else. It's like being transported to another planet.
I think people don't necessarily appreciate the difference between 99% and 100%, because that last 1% of the coverage of the everyday sun darkens the sky by a factor of 10,000 and allows us to see all the great phenomena.
And gosh, it was such an amazing experience that I got hooked, and now I chase eclipses all over the world.
In fact, David Barron has caught up with 5 eclipses so far.
Oh, only 5, huh?
Well, how many have you been to, Jay?
65. I'm pleased but not surprised that David Barron became an eclipse chaser, and we see that a lot. People who go to one just find it such a wonderful experience, they want to go to the next one and the one after that too.
Well, David Barron may need another 6 eclipses before he catches up to Jay Pasakoff, whom we'll hear from again later in the show. But meanwhile, Mr. Barron has written a book about the eclipse fever of 1878. American Eclipse, a nation's epic race to catch the shadow of the moon and win the glory of the world.
In 1878, the general outlines of modern America were in place. Although the nation had only 38 states, the national borders were pretty much as they are today. The Civil War was over, the Transcontinental Railroad had been completed less than a decade earlier, and people were embracing manifest destiny.
But America was an also-ran in science. In the mid-19th century, eclipses were not just awe-inspiring phenomena, but important to science, and Europe dominated the field. So when the time neared for the moon's shadow to cut a swath across the mountain states in 1878, a wave of eclipse fever seized the U.S., infecting scientists and general public alike.
Among those going west to witness totality were Maria Mitchell, the first professional female astronomer, and the newly famous inventor Thomas Edison. They each saw an opportunity to put the Europeans in the shade and shine a bright light on American science.
The mid to late 19th century has been referred to as the golden age of eclipse expeditions because, as you say, it was a time when total eclipses were very important to astronomy. Of course, they're very rare, and you've got to head off to the far corners of the Earth to see them. So during that era, European nations and the United States put together these expeditions to go sit in the path of the shadow of the moon, hope clouds wouldn't show up, and then conduct their studies frantically. And the reason was that at that stage, astronomy was just starting to unravel the mysteries of the sun. I mean, you can imagine, for most of human history, we always wondered, what is this great ball of fire in the sky? What is it made of? What fuels it? And there were certain studies that at that time astronomers were able to do using particularly spectroscopes, that they could, when the moon blocked the bright surface of the sun, they could use these instruments to study what appears around the sun, the solar corona, and start figuring out what elements are in there. And what is it? What is the corona? How does that explain what makes the sun shine?
Now, many of them, I would say the majority of them in the 19th century, were setting off from Europe. It had the interest, it had the money to send astronomers around the world to study these events. But the U.S. government hoped to horn in on that glory a little bit. How did they pique interest in sending some Americans off to see an eclipse?
Right. So this was a time when the United States really didn't get much respect on the international stage when it came to science. You know, we had just turned 100 years old a couple years before. So in 1876, we celebrated our centennial, and we were becoming an industrial power, but Europe really looked down their noses at us intellectually. The center of Western culture was Europe. That's where most of the great literature and art and music and science came from. But there was a small band of American scientists who, at that time, were determined to turn the United States into a global scientific power. Now, they were dealing with this democracy. If they wanted the United States to become a great power, they needed to convince the American public that this was worth investment and so forth. And in fact, in 1878, it took a long time for the scientists to get Congress to appropriate any money. In the end, Congress came up with $8,000, which wasn't even that much money back then. Obviously, it was more than it is today, to send the scientists out west. But it really was the determination of the individual scientists that they wanted to take advantage of this eclipse that was going to cross our own backyard and show Europe that we were to be taken seriously as scientists.
The public was apparently interested as well. It's remarkable to see a copy of the page from the Chicago Tribune a week before the eclipse with a full map of the path of totality across the country. Even though Chicago wasn't in that path, people still seemed to be interested.
Absolutely. You know, one of the things that really struck me in writing my book was that the eclipse chasing experience was pretty much the same in 1878 as it is today. Back then, they knew where the path of totality would be. People understood, for the most part, that a total eclipse was not something to be feared. It was a natural spectacle, something worth going out of your way to see. So there were eclipse tours that came out to Denver. A lot of folks came out. The hotels were overrun. They ran out of rooms. So folks were coming out here really to enjoy the spectacle. And even on street corners, people were selling eclipse glasses. Now, eclipse glasses back then were not the ones you'll get today with cardboard frames and Mylar lenses that are certified to be safe. But back in 1878, people were selling on street corners pieces of colored glass or smoked glass to witness the partial phases of the eclipse that came before totality.
Your book focuses on three characters who had personal and even professional reasons for viewing this eclipse, and they came out to the West along with other scientists in 1878. One was Thomas Edison. He's famous because, of course, he had invented the light bulb, the motion picture camera, phonograph. Why would Thomas Edison be interested in an astronomical event?
Yeah, that's an excellent question. And that, Thomas Edison's involvement in the eclipse of 1878 was really the first thing that got me hooked on this story. And just what an interesting collection of individuals and the period and just the setting. It all came together in such an interesting way. And Thomas Edison, who, as you say, of course, we know him today as a great inventor. And in fact, a lot of biographies of Edison portray him as someone who was disdainful of basic science. In fact, later in his life, he would talk about these ivory tower academics in quite negative terms. And he was adamant that he was not a scientist. But that was an older Thomas Edison. In 1878, Edison was a young 31 years old. He had just come out with the phonograph, and that launched him into international stardom. But at that phase of his career, he had great respect for academic scientists, and he, in fact, wanted, in some sense, he wanted the respect of scientists, and he kind of wanted to be one. And so in 1878, he came to Wyoming to study the solar eclipse with a bunch of academics. And he was specifically looking to answer a question about the solar corona, which today we know is the sun's outer atmosphere. But back then, it was just this strange apparition around the dark moon that you'd see during a total eclipse. And he was going to answer the question of whether the corona merely gave off light or if it also gave off heat. And he invented a device called the tosimeter, specifically to point it at the solar corona during those 3 minutes of totality and try to figure out, did the corona give off much heat? And so this was his chance to show himself a scientist.
Yeah, well, that would be a tough measurement, I think. As it turns out, the corona is at many millions of degrees. I don't know if it's tosimeter. I don't know how it worked, but I don't know if it could have detected that in any case because it's very low surface brightness. But let's talk about another character, James Craig Watson. This was an asteroid hunter, and he was looking for a planet called Vulcan. Sounds like something Spock might be interested in, that presumably orbited between the Sun and Mercury. Now, why did he think this planet exists, and how was he going to look for it?
Well, Vulcan, long before it ever showed up on Star Trek, back in the mid-1800s, was thought to be a real planet. And this goes back about 20 years before the eclipse of 1878. Astronomers were studying the orbit of Mercury, and when they studied its behavior, the planet's behavior, it didn't quite fit the predictions of Newtonian mechanics. And so the assumption was that something was perturbing Mercury's orbit. And the best explanation was that there must be a planet, or perhaps several planets, between Mercury and the Sun that were kind of tugging it along. But no one had ever reliably seen Vulcan. That, of course, wasn't a surprise, however. If you have a planet right next to the Sun, it's never going to be in the sky at night, and you can't see it in the daytime because it's lost in the glare. But during a total solar eclipse, when the moon completely blocks the face of the Sun, you might see Vulcan. And if anyone was going to find Vulcan, it was James Craig Watson, a man who was known throughout the world as one of the top asteroid hunters, and back then asteroids were considered planets. They were called minor planets. So basically you have James Craig Watson, who knew how to look at the sky and pick out something that wasn't actually a star but was a planet. And he was going to do that during the eclipse of 1878, and he put his reputation on the line looking for Vulcan.
Doesn't sound like a good idea in retrospect. I guess his success was comparable to Thomas Edison's.
Well, right. So I don't want to give away the entire story, but yes, James Craig Watson was determined to find Vulcan, and the big headline out of the eclipse of 1878 was that he found Vulcan, which probably you can guess didn't hold up over time. But that's in part what I find so interesting about the eclipse of 1878 is it's a forgotten scientific event because the scientific discoveries didn't pan out. But frankly, that's true of most of science, right? Most things that people look for, they don't find, or a lot of things they discover turn out not really to be there. But the eclipse of 1878, its lasting impact was really on American culture. It was a chance for the United States to come together, to rally around a scientific event, to try to take on Europe in science, to decide that science was a national goal we should all embrace. And how proud the general public was. You could read these articles at the time about how proud the American public was of its own team of scientists for taking on Europe, and it was a very proud day for this young nation.
Let's talk about one other person who went to the eclipse, Maria Mitchell, the first American woman to work professionally in astronomy. She set out with an all-female eclipse viewing party. What did she see as her role in creating this?
Yeah, I just love Maria Mitchell and had so much fun getting to know her in the course of writing my book. So Maria Mitchell was, back in the 1800s, in the late 1800s, she was a very well-known scientist in America. She was the best-known female scientist in this country. And, of course, as you can imagine, this was a time when working in science, if you were a woman, was very difficult. There were very few opportunities. You really were discriminated against in very obvious ways. And Maria Mitchell was a very outspoken proponent of women's rights, of women's higher education, and of women in science. And in 1878, when groups of men were assembling eclipse expeditions out to the American West, and when Vassar was excluded from the invitations that were sent out by the U.S. Naval Observatory, she decided she was going to take it upon herself to put together her own eclipse expedition, and that it would be an all-female expedition. And there's just this wonderful photograph I have in my book of the Vassar College eclipse party in Denver in 1878. These women in Victorian dresses sitting by their telescopes getting ready to study the eclipse.
Finally, David, where are you going to be on August 21st?
In Jackson, Wyoming, which sits right along the center line of the path of totality this year. And in fact, my plan is to be up on a mountaintop. I've got family members coming out, and we're going to be up at 10,000 feet on one of the Tetons looking west toward Idaho. And my goal is to actually see the moon's shadow as a great shaft of darkness from outer space rushing in from the west. And although I've seen 5 total solar eclipses, and they've all been amazing in their own way, I've never had a great view of the approach of the moon's shadow. And boy, that's what I want to see this year.
David Barron, thank you so very much for speaking with us.
Seth, it was my pleasure. Thank you.
David Barron is the author of American Eclipse, a nation's epic race to catch the shadow of the moon and win the glory of the world. Okay, when the moon's shadow passes over his Wyoming mountaintop, totality will have come and gone for this astronomer.
I'm a California resident, so the nearest place for Californians to go is Oregon. And I'm going to be in Central Oregon, where the weather is also promising to be good.
Coming up, Andrew Fracknoy tells you what you need to know to watch the Great American Eclipse.
Also later, what NASA hopes to learn from studying the sun. Looks like we're eclipsing all other shows on Big Picture Science. Hi, Seth here. You know about our SETI experiments, how we use the Allen Telescope Array in efforts to pick up radio signals that would tell us someone is out there. Well, the SETI Institute has been developing a new instrument to look for another kind of signal, very brief flashes of laser light. Now, if an extraterrestrial society was trying to get in touch, they might occasionally ping our world with such a flash, and you know what? No telescope would ever have seen it, because they're not looking. Well, we've designed a new instrument that can search the entire night sky all the time for these possible pings. It's called Laser SETI. I encourage you to find out more and even help out. Just go to laserseti.org. Easy peasy, laserseti.org. It could be more than enlightening. Okay, you're undoubtedly succumbing to eclipse fever, craving info on where to go and how to watch like a malaria patient with a thirst for quinine. Well, we've got the deets. First, think about your travel plans. Hotels will be booked, traffic will be viscous. But the second thing is a little less onerous. The items you need to watch the eclipse safely can be found at home, even on short notice.
He'll explain more in a moment, but here's astronomer Andrew Fracknoy's grab and dash list.
First of all, go to the kitchen and find your colander, because that's going to be a way to project a lot of pinhole images of the eclipsed sun on a sidewalk. Then I make sure that you have a big floppy hat and lots of sunscreen and a compact mirror or a hand mirror. I'd grab that and some cardboard, and we'll use that to make a reflector to show an image of the sun on a nearby wall.
The chair of the astronomy department at Foothill College is also the author of a children's book, When the Sun Goes Dark, that prepares young people for what is sure to be the greatest show off Earth for 2017, if not for their young lives. Ditto for their parents, and anyone else with eyeballs.
Well, this eclipse is going to cross the entire United States, and it's going to be the first eclipse to cross the U.S. in the internet age. So no one really knows what to be prepared for. What's interesting to us is that this eclipse is going to be total in one country and one country only, that's the United States, but the partial eclipse is going to be visible all over North America. So if you calculate the population, almost 500 million people will be able to see this eclipse. And I think that's going to be one of the most watched sky phenomena ever.
Okay, well, let's begin with where you can see the eclipse. Now, you've already said that anybody in North America will be able to see something, but the real drama is in the total solar eclipse. And where can people see that?
So in a total eclipse, the moon completely covers the sun. And by the way, that's a complete coincidence that as seen from Earth, the moon and the sun are the same size in the sky. So it's possible for the moon to get exactly in front of the sun and to block all of its light. That's called the total eclipse of the sun. And that total eclipse requires you to be directly under the dark shadow that the moon makes. And this time that dark shadow spot is only 60 to 70 miles across, so a relatively small width. And as the Earth turns and the moon moves in its orbit, this shadow spot will move across the country, starting on a beach in Oregon and ending on a beach in South Carolina. If you happen to be in that spot and in that zone, then you will see the total eclipse. You will see a darkness in the middle of the day and a spectacular showing of the sun's faint atmosphere.
Okay, so I think there are 12 states where the total solar eclipse actually occurs, if you want to be in that path.
But the fascinating thing about this particular eclipse is how many people are within driving distance of this total eclipse zone. Someone has calculated that 47 million people live within a 100-mile drive of the zone where the eclipse is total. And our fear is that at the last moment, a substantial number of those 47 million will decide, hey, what the heck, it's August, it's vacation time, it's Monday, we'll just take time off from work and we'll drive into the eclipse zone, and that there will be absolute gridlock the morning of the eclipse.
How would you compare this to the other revelatory event for people who hadn't been interested in astronomy before? That is, to see the rings of Saturn through a small telescope. A lot of people say that's really impressive. How impressive is a total solar eclipse?
Well, a total solar eclipse really is a once-in-a-lifetime experience, and many people say that you're not the same after you've seen one. What happens is that the sun is there in the sky like any other day, and then as the moon moves across the sun, you begin to see the whole world going darker and darker until suddenly it's night in the middle of the day. And the stars actually come out. And in this particular case, on August 21, we'll get to see Venus, which is not far from the sun this time around. and the whole world becomes this eerie twilight darkness. So the beauty and the awe and the eeriness of a total eclipse cannot be overemphasized.
Now, how long does it last? I mean, this airy that you experience.
So this is the bad news about this eclipse. This is an unusually short eclipse. Even in the best of places in the United States, the longest it'll last is about 2.5 minutes. In many places, not in the center of the shadow, it may only last a minute or a minute and a half. The thing about the rings of Saturn is that you can see them anytime. And on average, it takes hundreds of years before a total eclipse returns to any single part of the Earth. So if you are there in this eclipse zone, it's really a remarkable thing to be able to take advantage of. And here are 2 other quick tips for people who want to get into the total eclipse path. Number 1, there are wonderful maps available on the web. The NASA Eclipse website has a good interactive map, and Michael Zeiler, our cartographer, has put up a website called greatamericaneclipse.com, where there are detailed maps of each state where the total eclipse will be visible. The other thing I would just mention to people is that weather is going to play a very important role. If it's completely cloudy or foggy where you are, you won't be able to see anything. So please pay attention to weather reports on the days before the eclipse to make sure that the place you've picked has good weather.
Maybe the thing to do is just rent a jet and go up to 35,000 feet.
And there are actually real concerns that so many people are going to do that, fly private jets into the zone, that there's talk of the FAA grounding all private planes during the eclipse time.
But suppose you're one of those people that, doesn't want to drive up to the path of totality. Do you still see something worthwhile?
So for those people who are not in the direct path of the total eclipse, we will have a pretty substantial partial eclipse of the sun everywhere in the United States. For example, here in San Francisco, 76% of the sun's surface will be covered by the moon. In Washington, D.C., 81% of the sun will be covered. And the only thing that we need to say to all our listeners and to make sure they take this message away is that anywhere in the United States where you don't see the eclipse completely covering the sun, you need to protect your eyes. Looking at the sun, even when most of it is covered, can be quite dangerous. You can damage your eyes if you stare for a significant amount of time at the sun. So it's very important that where the eclipse is in total, you either have a pair of eclipse viewing glasses, special glasses that protect your eyes, or that you project an image of the sun so that you're not staring at the sun directly for any length of time.
Well, Andy, for people who don't have the glasses or the filters, the specialized filters, you mentioned earlier that there were kind of household items that they could still use to see the eclipse.
Yes, so here are some easy ways to project an image of the sun and protect your eyes. For one thing that you can do is to simply make a pinhole viewer. Take a piece of cardboard, make a small pinhole in it, and then have another piece of paper some distance away from it, and hold that pinhole over your shoulder pointing at the sun, and you'll get a tiny image of the sun on the piece of paper that you're holding some distance away from it. A much more dramatic way to do this is to use a colander. A colander in which you wash vegetables or fruit has lots of pinholes in it. And if you hold that over your shoulder with your back to the sun, you'll get a whole series of really very nice images of the eclipsed sun on the sidewalk in front of you. To get a slightly bigger image, what you might want to do is grab a compact mirror or a hand mirror, cover most of it up with cardboard, leaving a hole about the size of a dime, and then use that tiny uncovered part of the mirror to project an image of the sun, of the eclipsed sun, onto a wall near you. Now, one important thing about this is that it takes some practice to project an image of the sun, and you don't want to do this for the first time on August 21st. So probably on August 19th or 20th, you should be practicing with that covered compact mirror. If people want to get more detailed drawings and instructions on how to do safe viewing of the eclipse, the nonprofit National Science Teachers Association has put a booklet that I helped write on the web free of charge that anyone can download, which has information about when the eclipse will be visible in different cities and how you can make simple homemade viewing devices to help you observe it.
But what about the eclipse glasses for people who want to have those and don't want to go the pinhole camera route? Where can they get eclipse glasses? They probably don't need thousands of them, so can they just get a couple?
Certified safe eclipse viewing glasses are being distributed by public libraries in the United States. I'm part of a project, and we're distributing 2.2 million eclipse glasses free of charge through public libraries around the country.
You have a book, When the Sun Goes Dark, that's aimed at getting children and young astronomers interested in this eclipse. What's the hook of the book, so to speak?
Well, this is something we thought about quite a bit. So this is a chance, I think, for most young people to meet the idea of an eclipse for the first time, which is a picture book for kids ages 8 through 13, which not only talks a little bit about the eclipse in the form of a story, but helps families to act out an eclipse with everyday home materials. What kind of things can you do in your own home before August to get your kids understanding what happens during an eclipse, to get them maybe to make an eclipse in their own living room with a light bulb and a tennis ball, and therefore have them be much more clear on what's happening in the sky on August 21st.
So what about animals? I mean, are they a little confused? Do they think it's been an early nightfall?
Absolutely. It's fascinating to watch animals during an eclipse because they really don't know what's going on. How did it suddenly get to be night for their eyes when their stomachs are telling them it's not the right time for this to happen? There's actually going to be a citizen science project looking at how life other than humans responds to the eclipse. For humans as well as animals, this is a very unusual thing to see. And the placement of the light, the shadows, what you see during the eclipse is really something which is quite memorable and often confusing.
Finally, Andy, so solar eclipse happens, rather obviously, when you have a new moon, when the moon can get in front of the sun. So why don't we have a total solar eclipse every month? We have a new moon every month.
Yeah, this is an interesting sort of factor in the geometry of the solar system in which we live. It turns out that the moon's orbit is tilted relative to the orbit that we make around the sun, and therefore the sun appears to make in the sky every year as we go around it. Those two planes in the solar system have a tilt to them so that most of the time, when you think there might be an eclipse, actually the moon is above the sun in the sky or below the sun in the sky. But every 6 months, these two paths cross. Think of it like two hula hoops in the sky. When you have two hula hoops, they can cross in two places. And so every 6 months, we have eclipse season where eclipses are possible. Now, not every one of those times do we get a total eclipse of the sun. We might get only a partial eclipse, or where the moon is actually leaving a ring of light called an annular eclipse of the sun. But we get an eclipse possibility every 6 months, but it can happen anywhere on the Earth. And since 2/3 of the Earth's surface is water, much of the time, these spectacular eclipses are happening where nobody lives. Rich people can rent a yacht and go into the eclipse zone, but most of us don't get to see it. So that's what's exciting about August 21st, is that we're going to have an eclipse with the courtesy to come over very well-populated territory and make the spectacle available to all of us.
Andrew Fracknoy, thanks so very much for giving us the lowdown on the eclipse.
Thank you, Seth, and here's wishing all your listeners clear skies and good companions for August 21st.
Andrew Fracknoy is chair of the astronomy department at Foothill College, and he is the author of the children's book, When the Sun Goes Dark. For more information on the tips that Andy mentioned, where to get maps and glasses, for example, check out the links on our website, bigpicturescience.org.
Astronomer Jay Pasakoff has one more travel tip for eclipse road trippers. Brew that coffee early.
If you're not actually sleeping in the zone of totality and you have to drive into the zone, there are going to be terrible traffic jams. Midnight the night before, that's when I recommend you leave. It doesn't matter how far in the zone of totality you are, as long as you're in the zone.
It's obvious that the 2017 eclipse will deliver spine-tingling thrills. Dr. Pasakoff tells how it will also deliver on the research. The Science of the Sun next.
Looks like we are eclipsing all other shows on Big Picture Science.
The star that is our sun seems like a big ball of hot gas, but it's not quite all that simple. The sun has an atmosphere that extends beyond that ball, and the outer atmosphere, a faint halo of very hot gases, far larger than the sun itself, is called the corona. Now, it's only visible when you block out the bright direct light from the sun's disk, and when the moon does that, as Andrew Fracknoy reminds us, the effect is wow.
You can see streamers of light. You can see the variations and changes in this atmosphere of the sun. Occasionally, you can even see little bits of hot material being launched off the sun into the solar system at large.
That prompts the oohs and the ahs from the eclipse watchers, but does it score data points among the pointy-headed researchers as well? Scientists could learn a lot from eclipses in 1878, when the nation was told to go west. Is the same true of eclipses today?
Well, let's just say that astronomer Jay Pasakoff is sufficiently motivated by the promise of scientific reward in 2017 to travel from Williamstown, Massachusetts to Salem, Oregon with a caravan of 25 family members, 8 Williams College students, and 60 astronomers, colleagues, alumni, and tourists. He has no idea who's in charge of snacks, but he's bringing the high-tech instruments for sure.
Telescopes of varying sizes and a couple of spectrographs, and we have some very fast readout electronic detectors. We got time on the Very Large Array radio telescope in New Mexico. So I've really tried to be very ecumenical to study this eclipse in every conceivable way that I could think of.
One of the questions astronomers want to answer, why is the corona so darned hot? It's even hotter than the fusing interior of the sun, and far, far hotter than the sun's roiling, boiling surface. Sure, our spacecraft might answer that question, but Dr. Pasakoff knows that there's still no substitute for ground-based observation.
Some people mistakenly think that we can see the corona as well from space as we can from the ground. But the whole region that we see at an eclipse so well in such detail in ordinary light is not visible from any spacecraft. The so-called coronagraphs that are aloft hide more than the first inner radius of the sun, leaving a whole region that's just for us to study during an eclipse. So only every 18 months or so, somewhere in the world, can we get a complete picture of the sun as it is on that day. And so we're going to do our best to do that on August 21st this year.
Well, I'll let me press you a little bit on that, because it seems to me very naively that if somebody were on the International Space Station and held up a dime in front of their eyes, maybe 10 feet in front of their eyes, but whatever, they could make an eclipse, a total solar eclipse, anytime they wanted. So, and then we also have satellites, SOHO and others, that's the Solar and Heliospheric Observatory, looping around the sun in space. They're a lot closer to the sun than Oregon is. Why go to Oregon?
Well, I can have bigger equipment than they have. My equipment is a little bigger and better than just holding up a dime. And also, there are new advances in electronics. The SOHO's coronagraphs were launched in 1995. We have a fast readout CCDs, the electronic detectors now, that we'll be using at this eclipse to look for very fast oscillations, to see if that's what's making the corona over 1 million degrees. And there's no other way to do that. There's no spacecraft that can image so fast, and there's no spacecraft that can see this whole donut of corona around the sun for the first radius or so above the edge of the sun.
Maybe you could expand on that a little bit, because clearly in the previous century, or I should say the 19th century, 1878, the American Eclipse expedition had a very clear science goal to answer some basic questions about the sun. How have those science questions changed?
They were using film at that time, and the electronics we have are about 100 times more sensitive than films. So we can take many images and see things varying in the sun in a way that couldn't be done photographically. It wasn't discovered till about 1940 that the corona was 1 million degrees. So the whole set of questions about how the corona is heated, whether it has to do with oscillations on loops of coronal gas low in the corona, or whether it has to do with what we call nano flares, a lot of flares, billions of them going off all the time on a very small scale. There are just scientific questions that have come up more recently, and there are kinds of observations that we have equipment for that the people from 100 years ago couldn't even dream about.
Now, you've talked a lot here about the corona. For those people who don't know, maybe you could explain what the corona is and how they'll be able to see it.
If you're in the 100% coverage, the zone of totality, then it gets really as dark as a dark twilight, and you see what you can call a crown, and the Latin word is corona, around the sun that comes into view when the sky darkens, when the blue sky goes away. It turns out it's hot gas in space that's held in place in beautiful shapes by the magnetic field that goes out in the corona, and we're working with people who are trying to use the equations of physics to predict what the shapes will be. In fact, there are people on Earth trying to use magnetic fields to hold hot gas in place to make fusion for energy on Earth. And the magnetic field turns inside out in a fraction of a second when we do it on the Earth. We're helping to learn and improve the laws that govern how magnetic field holds hot gases in space.
Well, finally, Jay, it certainly sounds as if there's still research reward for scientific study of eclipses from the ground. But, looking to the future as we put more telescopes in space and eventually on the moon, well, are you still going to be taking future students to these eclipse sites?
In 1990, I was pleased to be invited to the Institute for Advanced Study at Princeton, Einstein's old place, by John Bacall, one of the major astronomers of the last century. And he got me also on NASA's Astrophysics Council, which was a high-level group of people meeting in Washington, D.C. And I went to the first meeting, I remember, and we spent 2.5 hours discussing what we were going to put on the moon with the first set of telescopes to go to the moon. So that's now, they see 1990, if I subtract right, that's 27 years ago. So the progress hasn't been as fast as we hoped then. So eventually we'll be able to do all this from space, and we'll fly spacecraft in tandem and make artificial eclipses and have good stuff on the moon. But that's not happening right away. There's still a lot of time for us to do our eclipse research.
Jay Pasachoff, thanks so very much for speaking with us.
You're very welcome. I'm very glad to be invited. Enjoy the eclipse.
Jay Pasachoff is an astronomer at Williams College and the chair of the International Astronomical Union Working Group on Solar Eclipses. Okay, the ground is where he's bound to watch the moon cross the sun, but for heliophysicist Lika Guha-Takurta, space is the place to greet the sun up close.
When it launches in the summer of 2018, NASA's Parker Solar Probe will be the very first spacecraft to visit a star up close and personal. By going straight to the source, it will be able to make observations that other spacecraft, or even eclipse chasers, can't, and help unravel not only the corona question, but also questions about the nature of the solar wind. Dr. Guha-Takurta says the mission is a chance to touch, taste, and smell our sun. Now, that is close, but this spacecraft can take the heat.
So the temperature is kind of pretty toasty. It's, on an average between 1 and 2 million degrees Kelvin. Pretty hot.
Okay, so you have the spacecraft. It's on a pioneer mission, and it is tough, and it's ready to observe the sun. And I wonder if we could just say something about the object of its observation. I read on your Twitter page the statement that the sun is new each day. How is the sun new every day?
For a fascinating question. And, that's not, I used Heraclius's line on my Twitter page, and it is so true. When we look at the sun every day, the sun appears like a constant yellow ball in the sky. But that's in the visible wavelength. But if we were able to look at the sun in other wavelengths, for example, ultraviolet or soft X-ray or X-ray, all of a sudden you begin to see this very dynamic sun. And that's what we are doing. We are flying spacecraft, that's looking at the sun 24/7.
So these are other missions that have been or are looking at the sun, and they're looking at the sun in different wavelengths. How will the Parker Solar Probe be different in its observations of the sun, or will it observe under some of these same wavelengths as well?
So this is indeed a very important question. So when we have been observing the sun, typically we have done this with telescopes. So what we are doing is we are observing the sun from a distant spot. It's called remote sensing observations. We're taking images of the sun.
That's what we're doing now.
That's what we are doing now. But what is fascinating is that we have learned so much about the sun through those observations. Yet, we really can't completely answer the question, why is the corona so hot? The surface of the sun, the yellow sun, is only about 5,000 to 6,000 degrees Celsius. And the corona is millions of degrees, right? Common sense says if you move away from a source of fire, that the temperature is going to go down. Well, this is completely opposite to that. The temperature is going up. First question that we have to answer is what makes the corona so hot? Second question is that the solar wind is actually escaping, right? So these are particles escaping the gravitational pull of the sun. So the pull and push is the pull of sun's gravity, and the push away is the kinetic energy of the particles, right? So high temperature means high kinetic energy. And that energy is sufficient for the particles to escape. But this energy has to be continuously replenished. Otherwise, the solar wind would stop blowing. So what kind of dumps this energy into the corona? What accelerates the solar wind? These are not only important questions in solar physics, but these are some of the fundamental questions of physics. And so to do that, what we have to do is actually we have to go into the environment of the sun and measure the plasma, the electrons, the protons, the ions, their velocity, density, magnetic field.
So you're going straight to the source.
We're going straight to the source.
And I wonder if there's almost a tactile aspect to being this close to our star. And in fact, you were quoted as saying that this probe will allow us to touch, taste, and smell our sun. Do you stand behind that? And can you tell me what the sun might smell like?
I do. And it is like, it's the sampling that we are going to do, right? Touching is with these local instruments, right? We are actually going to sample the environment. We are going to measure the density
of the corona.
That's like touching it, And then you can sort of, the spectroscopic experiments that we'll do temperature, we will do velocity, we will do magnetic field. In a way, how we color code the universe. If we were looking at Hubble pictures as they came, black and white, it wouldn't be that interesting. The fact that we gave them a color code just opened up the universe in front of us. So you can take all these observations and sort of ascribe to them, a smell, or a sound or a touch. It is almost like that in my mind.
Well, finally, Lika, although this mission is going straight to the source, as we've said, it's going to the sun itself, can you still make a pitch for the importance of the 2017 solar eclipse in August?
There are no words to even say how important this is, right? But imagine actually seeing that outer atmosphere of the sun. I call it the living, breathing star. And you're seeing this shimmering glow of the corona, escaping gradually, and imagining that we actually live in the outer atmosphere of the star, and we are seeing that with our unaided eyes. I think it makes a connection that I don't know what else does. I mean, it's our connection to our parent star, but to the cosmos or universe in a big picture way.
Thank you so much for speaking with us.
Thank you.
Lika Guhatakurta is a heliophysicist at NASA Ames Research Center and also a NASA headquarters in Washington, D.C. So I think what we've heard in the show is pretty unequivocal. Go see the eclipse. And you're more lucky than you even realized. I looked up all the 160, whatever it was, moons in our solar system to see where else you could see a total solar eclipse. The only place I found was Jupiter. And I can tell you, the accommodations are not good.
Thanks to the team that never throws shade in helping us produce the show, Senior Producer Gary Niederhoff, Operations Manager Barbara Vance, and Intern Daniel Marino.
Thanks also to financial support from Rena Shulsky-David and Sammy David, and to the William K. Bowes Jr. Foundation. Big Picture Science is produced at the SETI Institute, a nonprofit scientific and education organization whose scientists study the origin and nature of life, including planets around stars that aren't the sun. And a big thanks also to our listeners.
Your ears have been attuned to a special Solar Eclipse 2017 episode of Big Picture Science. The episode is called Eclipsing All Other Shows. If you want to hear more Big Picture Science episodes but you can't find them, no need to take umbrage. They are in our archive at bigpicturescience.org.
And if you are a podcast listener but prefer listening to over-the-air radio because you always have the chance that a solar storm will make reception dicey, check out the listing on our website of radio stations that carry the program. And if your local station is not on that list, consider letting them know you liked this show. Just a beautiful eclipse. Couldn't hope for better.
Here we go with the diamond ring coming up.
Yeah.